Hello, my dear friends, welcome to the YouTube channel. Buffer solutions. Buffer action. The ability of a solution to resist large changes in pH upon the addition of a small amount of either acid or base is called buffer action. The solutions that possess this property are the buffer solutions. Hence, a buffer solution is defined as a solution which resists drastic changes in pH upon the addition of a small amount of either an acid or a base. A buffer solution is said to possess reserve acidity and reserve alkalinity. In other words, it contains an acidic component and a basic component. If a small amount of base OH minus ions is added to a buffer solution, pH increases very little because the acid component, reserve acidity of the buffer solution, neutralizes the added OH minus ions. If a small amount of acid H plus ions is added to a buffer solution, the pH decreases only slightly because the base component, reserve alkalinity of the buffer solution, neutralizes the added H plus ions. Types of buffer solutions. There are two types of buffer solutions. Acidic buffer solution. A solution containing a weak acid and the soluble ionic salt of the weak acid with a strong base is called acidic buffer solution. For example, a solution containing weak acid such as CH3COOH and its salt CH3COONA is an acidic buffer solution. It is prepared by dissolving nearly the same molar amounts of CH3COOH and CH3COONA in water. Mechanism of acidic water. In CH3COOH, CH3COONA buffer, more acidic component, reserve acidity is CH3COOH, and more basic component, reserve alkalinity is CH3COO minus ions supplied by the salt. The acid and the salt dissociate as CH3COOH aqueous to CH3COO minus aqueous plus H plus aqueous partial. CH3COONA aqueous gives CH3COO minus aqueous plus Na plus aqueous complete. Suppose that a small amount of strong acid is added to the buffer solution. The H plus ions of the acid react with the basic component CH3COO minus ions in the buffer. CH3COO minus plus H plus gives CH3COOH aqueous. Most of the added H plus ions are consumed because the concentration of CH3COO minus in the buffer solution is high. The reaction nearly goes to the completion because CH3COOH is a weak acid and its ions have strong tendency to form non-ionized CH3COOH molecules. Due to the removal of most of the added H plus ions, there is no appreciable decrease in pH. If a small quantity of base is added to the buffer solution, the OH minus ions are consumed by the acidic component CH3COOH. CH3COOH plus OH minus gives CH3COO minus plus H2 in liquid form. The effect is neutralization of most of the added OH minus ions by CH3COOH. Therefore, there is no appreciable change in pH. Basic buffer solution. A solution containing a weak base and a soluble ionic salt of the weak base with a strong acid is called basic buffer solution. For example, a solution containing a weak base such as CnH4OH and its salt NH4Cl is a basic buffer solution. It is prepared by adding comparable nearly equal molar amounts of NH4OH and NH4Cl in water. Mechanism of basic buffer solution. In NH4OH, NH4Cl basic buffer, more acidic component, reserve acidity is NH4 plus ions and the more basic component, reserve alkalinity is NH4OH. The base and the salt ionize as NH4OH equivalent to NH4 plus aqueous plus OH minus aqueous partial. NH4Cl aqueous gives NH4 plus aqueous plus Cl minus aqueous complete. If a small amount of strong acid is added to the buffer solution, the H plus ions are consumed by NH4OH. NH4OH plus H plus aqueous gives NH4 plus water. Thus, most of the added H plus ions are neutralized by NH4OH and there is no appreciable change in pH. When a small amount of base is added to the buffer solution, the OH minus ions react with the NH4 plus ions to produce non-ionized NH4OH molecules. NH4 plus OH minus aqueous gives NH4OH aqueous. The concentration of NH4 plus ions is high in the buffer solution. Hence, most of the added OH minus ions are consumed. The reaction goes nearly to completion because NH4OH is a weak base and in its ions have strong tendency to form non-ionized NH4OH molecules. Thus, there is no appreciable increase in pH. Properties of buffer solutions. The pH of buffer solution does not change appreciably upon the addition of small amount of either strong acid or strong base. The pH of buffer solution does not depend on the volume of solution. Hence, buffer solution can be diluted without the change in pH. The pH of buffer solution remains constant even if it is kept for a long time. If you like this video, please like, comment and subscribe. Thank you.